In 2023, a mysterious object entered our solar system, moving in a way that didn't quite make sense. It's called 3I/ATLAS, and some scientists think it might not be a natural body at all. But what could make experts even whisper the words alien probe? Today, we're breaking down the facts, the speculation, and what 3I/ATLAS can tell us about who or what might be out there watching. Astronomers first noticed 3I/ATLAS cutting into the solar system from a path that instantly stood out. Its speed was far higher than what we'd expect from an object trapped in our sun's gravity, and the angle it entered from didn't match any known orbit of local bodies. Those two pieces together pointed to one conclusion. It came from beyond our solar system, an interstellar traveler just passing through. We've only had 2 confirmed interstellar visitors before this. The first, Oumuamua, raced past in 2017. It was oddly elongated, didn't show the kind of tail we see in comets, and had a small acceleration that couldn't be fully explained at the time. Then came Borisov in 2019, which looked and behaved far more like a standard comet, icy, releasing gas, and with a well-understood trajectory. 3I/Atlas immediately invited comparison to both, but as data came in, it didn't sit neatly in either category. Its motion is one of those details that won't let scientists relax. The path it follows is hyperbolic, meaning it's not looping around the sun like planets or comets do. It's making a one-way trip. Objects on hyperbolic trajectories are like express trains that can't be stopped. They enter, pass by, and keep going into deep space. That alone is consistent with an interstellar origin. What's less straightforward is how it's moving on that curve. Small deviations in its speed don't perfectly fit the models we use for comets or asteroids. We've seen unusual readings like this before. Oumuamua showed that mysterious acceleration, later linked by some researchers to possible outgassing we couldn't see, jets of material pushing it. But no solid evidence confirmed that. Other comets have tricked us too. For example, Comet 2P/Encke shows strange orbital shifts due to uneven heating on its surface, but at least in those cases we can see the gas venting. In 3I/ATLAS, the signs are harder to pin down. Looking at telescope images and spectrographic data, the results are curious. The spectrum shows some features we might expect from icy bodies, but lacks the clear, active gas emissions typical of a comet on approach to the sun. It's like spotting a ship on the horizon that's moving against the tides and currents but without smoke from its funnel or sails on its masts. And yet, it presses on in a straight, fast course through a busy harbour of planets and asteroids, barely interacting with anything. The initial idea was to chalk this up to faint outgassing, tiny amounts of frozen gas evaporating as sunlight warmed its surface, creating a subtle push. That works well as an explanation for many comets. But for 3I/ATLAS, the match isn't perfect. The type and amount of gases expected aren't obvious in the data, and the calculated changes in motion don't fully align with the numbers researchers get from standard thermal models. That's why a few scientists have pointed out that its acceleration patterns are a puzzle. They're minor, but in orbital mechanics, small mismatches can be the difference between we understand it and we don't. With 3I/ATLAS, the puzzle pieces fit together awkwardly, enough for basic sense-making, but with gaps that refuse to close. And it's exactly those uncooperative details that have made some people pause. Because every time a natural explanation slips or feels incomplete, it leaves just enough space for more speculative, and much more controversial, ideas to slip in. If the physics doesn't match what we expect from a natural rock or ice body, could there be another explanation? That's where some scientists bring up a more unconventional idea. Maybe an object like 3I/ATLAS could be artificial. Not artificial in the sense of a broken satellite falling from orbit, but something built somewhere else, with a purpose we can only guess at. One name that often comes up in these discussions is Avi Loeb, who's spoken about the possibility that certain interstellar objects might be probes sent by extraterrestrial civilizations. The basic idea is that if a technology-using species evolved somewhere else, they might send out autonomous craft to quietly pass through star systems, scanning planets, taking measurements, or simply keeping a record of what's out there. These wouldn't need to land or even slow down. They could zip through, gather data, and send it back across light years. But here's where the tension starts. In mainstream astronomy, the bar for evidence is extremely high. Claims about alien-built probes need rock-solid proof, because extraordinary ideas require extraordinary support. Most researchers lean towards simpler explanations, like unfamiliar comet activity or odd fragment shapes, rather than leap to technological origins. That's not close-mindedness. It's about preventing conclusions that go beyond what the data can carry. If you do imagine a probe, though, its functions could vary. It might be a passive listener, using sensitive instruments to capture radio signals or magnetic fields. Or it could be an optical sensor, mapping a planet's surface details. In theory, it might even replicate itself, launching copies toward other nearby star systems, though right now that's firmly in the realm of speculation. Observers have set some markers for what might hint at an artificial object. Unusual shapes are a big one, like extreme elongation or razor-thin profiles that are rare in nature but useful for steering or energy collection. Reflective surfaces could suggest materials like metal or mirrors instead of rock and ice. And then there's unexplained acceleration, movement that doesn't match the push and pull of gravity alone. We've been down this road before. Back in 2017, Oumuamua's odd behavior led to proposals about sails or other artificial designs. The idea caught attention, but ultimately many in the scientific community stuck with natural explanations like outgassing, erosion, or fragmentation, things we have observed before, even if not in exactly that form. The disagreement shows how small differences in interpreting data can lead to very different narratives. It's a bit like hiking deep into untouched wilderness, kicking over a rock, and finding a small, perfectly machined metal gear lying in the dirt. Your first instinct might be to think of dropped tools or debris from human activity, but if it's genuinely far from any settlement, the questions come fast. What is it? Who made it? And how did it end up here? That feeling of mismatch is what sparks the what if, with 3I/ATLAS. In its case, a few data points raise eyebrows. Some researchers note possible non-gravitational changes in motion that don't cleanly fit the comet models applied so far. The numbers aren't dramatic, but in astronomy, small differences can carry meaning. The absence of strong visible outgassing also makes those changes harder to attribute to known physical effects. Still, none of this reaches the level of proof needed to call it artificial. Even so, exploring these possibilities isn't wasted effort. It forces teams to sharpen their observation techniques and refine models for how interstellar bodies behave. That way, when another unusual object comes charging in from the dark between stars, we'll know exactly what to look for and be ready to capture every clue it offers. Whether 3I/ATLAS turns out to be natural or something we've never seen before, it's already made one thing clear. We need better tools and faster responses when these rare visitors appear. Objects like this move quickly, and once they're gone, so are the clues they carry. The next interstellar traveler might reveal more about how our galaxy works, or even hint at life beyond Earth. But that will only happen if we're ready to collect every possible measurement from the first moment it's spotted. Curiosity drives that readiness, and it's exactly what keeps our search for answers moving forward.